Balloons are used to mark special occasions or to brighten up a day for young and old people alike. But balloons weren't always so delightful. In earlier days, they were made of dried animal bladders, a bit of an unpleasant concept. In the 19th century, someone invented a rubber balloon, which we still use today. They started mass-producing balloons in the 1930s, and today they're everywhere. To make balloons, they pour dye into a tank of latex. They filter it through cheesecloth to remove any lumps. Agitators at the bottom of the tank mix it up for 15 or 16 hours. This distributes the color, and it also keeps the latex active so it doesn't congeal. Balloons come in 53 different shades. Nozzles spray hot water onto balloon forms to clean them as they move on a system of rollers. A fixture then flips and dips the forms into a tank of coagulant that carries an electrochemical charge which will attract the colored latex. On top of this fixture are balloon forms freshly dipped in blue latex, while below, a tank full of latex rises, coating more forms on the underside. The job done, the fixture flips back, moving the balloon forms to an upright position, while below, another tray of balloon forms takes the plunge. The latex dries quickly as a conveyor moves the balloon forms forward towards spiraling brushes. The brushes roll up the bottoms of the balloons, creating lips. The lips will make it possible for people to grip the balloons in order to inflate them. The fixture flips again, and the balloons nosedive into a hot water bath. They soak for up to 16 minutes. This step is critical. It leaches out all the impurities, including a protein that causes latex allergies. The hot bath also triggers vulcanization, or rubberizes the latex. The balloons travel to another station. Here, the fixture dips them in a mix of talcum powder and water. This will allow them to be more easily stripped off the form. And now it's time for the forms to shed their latex skins. As the forms pass through this station, air jets inflate the balloons. Rollers at the top grab the balloons as they fill with air and pull them away from the forms. The rollers shoot the balloons upward, and they topple onto a conveyor belt. Next, a worker piles the balloons into an industrial washing machine and adds a cleaning solution. The machine heats to a steamy 160 degrees Fahrenheit, while the balloons tumble and nozzles spray water into it. This doesn't just clean the balloons, it completes the vulcanization of the latex. Now it's time to see if they can stand the test of inflation. A machine blows air into a huge heart-shaped balloon, and the heart swells but doesn't break. She holds it against a light to check for imperfections like blisters. Now it's time to blow some up. They're sure to brighten up your day.
When you start your car, it activates a pump that's usually located inside the gas tank. This electrical system pushes the gas out of the tank and into injectors, which aerate the gas and deliver it to the engine cylinders. Without a pump to get the fuel flowing, your car would be going nowhere fast. You might think that submerging an electric pump in gasoline would be a risky thing, but liquid fuel can't explode, so it's actually a very safe place to be. Production begins with the pumping mechanism. A gear and several rollers are sandwiched between two metal plates. The rollers will rotate to pull fuel into the pump before pushing it out of the tank. Each roller assembly is tested by spinning it from the bottom. A robot then pops it out and moves it to the next station. Here, the electric motor is attached to the roller pumping mechanism. Then, it gets a magnetic sleeve and a plastic cap. All the parts that make up the pumping mechanism have now been assembled. Next comes an end cap with a filter made of metal mesh. A metal sleeve slides over the pump unit and the whole thing is press fit together. Inside this chamber, large magnets generate a very strong force field. This causes the metal sleeve to collapse, crimping at one end, so that it holds everything together. Next, retainer rings go into slots in the fuel pump cap. A metal bracket goes over the pump. It steadies the assembly and serves as a guide as workers install the brushes and coils, which will supply electricity to the fuel pump motor. A brass terminal slides onto the end of each coil and brush assembly to facilitate the electrical connection. Then, the terminals are attached to the assembly. When the job is done, a robot removes the bracket. They've built this fuel pump from the inside out, and now the actual workings are complete. Inspectors hook each pump up to a power source and run fluid through them to test the pumping action. Then they check for proper flow and pressure. If the pump passes inspection, a robot sends it down the assembly line, where a tubing system is being assembled to carry the gasoline to the engine. The joints are sealed with a brazing paste. Then it's into a gas oven where the paste hardens and fuses to the tubing. Workers remove the tubing from the oven and brush off any unwanted bits of metal and hardened paste. The ends of the apparatus are capped to keep them from collecting dirt and debris during shipping. Rubber tubing is attached to the pump and secured with metal clamps. Then, the rubber tubing is clamped to the metal tubing system. Workers wire the fuel pump, then hook up a connector which will attach to the engine's wiring. This is the sending unit. It's a float with a metal arm that's attached to an electronic sensor. The sensor sends information about fuel levels to the fuel gauge on the dashboard. A computerized system checks the sending unit's accuracy as the sensor is moved up and down. Once everything checks out, it's time to fill the tank and hit the road.